talk about how to check IP route programming on the Juniper devices. So sometimes we know that we learn a particular routing information through protocols like BGP, OSPF, ISIS, even static, for example. But we may encounter situations where that routing information sometimes we want to ensure that they are correctly programmed on the hardware itself. This is just to make sure that everything is correctly happening so that we know that the traffic is going on the right exit point. So how do we check that? So normally, as most of you are aware, we will be using show route as a command with the prefix to identify the routing information. Now we need to understand in terms of Juniper, when you do show route, you are actually looking at the RIB information, which is the RIB, you call it the routing information base. This is after the updates are processed, whether it be OSPF updates, BGP updates. They normally enter the RIB in, and eventually, after all the policies and everything is applied, the route gets into the RIB, which is what the show route command is showing. Now from here, the routes are pushed to the kernel route table, and only after that the kernel route table will be able to push the route to the line card or the PFE, which we also call the FPC. So as you can see in the diagram here, we have three-stage process. So once you see a route on the show route, which is a part of the RIB information, you will can also verify that that route is also displayed on the kernel route table. We also call it the show KRTQ. So the command that displays the kernel route table is displayed here in the diagram. We will look at it in the demonstration as well. Eventually, after the kernel has that information that it had learned from the RIB, it will push it to the PFE, and on the PFE also you can check whether the routing is programmed correctly. So these are three steps that you can do to check your IP route programming is correct. For MPLS, the commands may be slightly different. We will look at that in another video. Now quickly jumping on to an example here. So here on the router, I'm doing the show route for a prefix. So let me just pick a prefix. So show route for this prefix. So when I do show route, I'm actually looking at the RIB table. So I know that the information is there, as I can see an ISIS route and an LDP label push happening. So now to check on the kernel side of it, so show route forwarding table, you can give family. After family, you can notice that we have lot of options. If it's an IPv4 route, you give INET. If it's an IPv6, you can give INET6, or if it's an MPLS, you can also give MPLS. In our case, it is an INET, so I'm just going to give INET, family INET, as you can see, with the destination of the same address. So now I'm checking the kernel route table. Now on the kernel route table, I can see that it is correctly pointing to the outgoing interface, which is AE9. This is exactly what you saw on the RIB information as well. The outgoing interface was AE9. So I know now that the kernel is also programmed with the correct information. Now going one step further, after this, the route is pushed to the line card. So I'm logging into the line card. So within the line card, the command is show route proto. If you give question mark within proto, you can see you have list of protocols for which you're looking for the route. So in my case, it is IP. I give the prefix, the keyword as prefix, and then I just copy the prefix for which I'm checking the route table. Now here you can see that the information is also displayed. I can see the route is there programmed on the line card. These informations are related to the next stop index that is internal to the hardware implementation, but the key is you can see that the route is available. Now what is interesting is you can notice indexes. Some of them have default routes with action as reject. In our case, we know that this particular route is a unicast route that's allowed. It's not like a reject or discard. Now what does index 0 or 1 or 2 indicate? There is a command for it. So if you do show route table, you can see the indexes are listed here. So default or the global INET table is index 0. So there are other routing tables, private, which is index 1, 2, some VRFs which will have their own indexes. So what this is telling is I am looking at the global routing table, which is of my point of interest, which is a part of the index 0, for which I have a route, which is a unicast next stop. Now there are other informations on other routing tables, like for example, this VRF 1796, maybe we'll pick 1797. You can see it's got a default route, but that's a reject action. So this is just giving us the confirmation that the route programming is all good. Hope this is useful. We will look into another video about MPLS programming. Bye for now.